Today we are going to extend our knowledge of logarithms by incorporating some of the laws of, or some of the rules that you use when you simplify logarithmic expressions. Now, if you think about some of the laws we've already had, like this is a very common one that we've just been using. This would be the, oops, it's n right there, product uh, property for exponents, and so we have a law that just says that can be simplified as a to the n plus n. The logarithmic laws are very similar to these exponent laws, so they're just some rules that we can apply to help us simplify expressions. The first thing we're going to do is just look at two little log problems here, and we're going to use our calculator for it. So I'm going to take the log 2. So if you watch on my calculator over there, get to the screen with my logs on it. Now the log 2 is a log base 10 of 2. So let's type in our 2, log base 10 it. So that's about 0.301. But I'm just going to go plus 10, oops, 100 rather, log base 10, and I'll add them together. So that does the whole business in one move, so it's about equal to 2.301. I'm going to clear this now, calculate the next one, log 200, so 200, and my log button, and I get approximately 2.301. And obviously I chose these two for a reason. Look at the outcome. So there must be some relationship, or maybe some relationship, between this log 2 and this 100 and log 200. Let's look at another numerical example of this, see if it works again. This time we got log 3 plus log 5. Let's see what that is. So I'll go 3 log plus 5 log. It comes out to about 0.690, and then we'll do the log of 15. And that didn't work out at all. So let me try the 15, a log of that, 1.176. Let me try my log 3 plus log 5 again. Otherwise, everything's going to fall apart. There's my log 3 plus. There we go. They do indeed match, as they should. So 1.176. So again, we get the same result. So in the previous one, it was a 2 and 100, and then we made it 200. So that was the first one on the previous slide. And then this one we had a 3 and a 5 and 15. So if you notice, there's a relationship. 3 times 5 is 15. 2 times 100 is 200. And this is what the first law is about. And the law basically takes a sum of two logarithms and makes it equivalent to the log of the product of those two arguments. So let's look at it written down in mathematical form. So you have a logarithm base b of two numbers multiplied together, or two variables in this case. It is equivalent to two logarithms, and one's the log of m, the first factor, plus log of n, the second factor. So a logarithm of multiplication can be broken up into the sum of two logarithms. Let's look at how we can exploit this, or how actually you are checked to see if you understand it. So assuming we don't have a calculator, and that's what the game we play, it used to be that you'd have to look up logarithms in a table. And so we've looked up some logarithms here. Log base 2 of 3 is equal to this, about 1.585. And log base 2 of 7 is equal to this 2.807. And the challenge we are given now is based on that information. Can you figure out what log base 2 of 21 is? And so here's the game we play. I know what log 3 is, and I know what log 7 is. So if I could rewrite this 21 as a combination of 3's and 7's, then I would be able to figure this logarithm out. So I'm going to think of this as a log base 2 of a 3 times 7. That's how I can get 21 and use the 3 and the 7. Then I'm going to apply this law up here, which says if you have a product in the logarithm, which I do, 3 times 7, I can break it up into two separate logarithms. And so now I can rewrite it as log base 2 of the 3 plus log base 2 of the 7. And it turns out I know what this is because I've got it right here. That's 1.585. And I'm going to add on the 2.807 because that's what the log base 2 of 7 is. And I'm going to run to my calculator and just add those up. 1.585 plus 2.807. It comes out to about 4.392. And we're done. That is the product property. Next one is the quotient property. Okay, I should have calculated these things before ahead of time, I think. Log of 3/8. So on my calculator, I'm going to find out what that is. 3 divided by 8 equals, and then I'm going to log that. So it's negative 0.426. And if I do the log 3 minus log 8, it comes out to 0.426 also. In the previous one, the product property, the multiplication, we could rewrite as an addition problem. So like 20 or 200, we could write it as a log 2 plus log 100. When you're doing a log of a division problem, it actually can be broken up into the numerator, or the log of the numerator, minus the log of the denominator. So instead of a addition, it's a subtraction inside the function. So here it is formally written down. If you have log base b of a ratio, you can rewrite it as log of m minus log n. So division becomes subtraction. So we have the same challenge down below here. They tell us what log 3 is and tell us what log base 2 of 7 is. They say figure out what the log base 2 of 3/7 is. And that is a straightforward apply this law. Rewrite it as log base 2 of the numerator minus log base 2 of the denominator. Log base 2 of 3 is 1.585 minus log of 2, log base 2 of 7 is 2.807. Grab your calculator to get your final result. 1.585 minus 2.8. So there we go. We solved that problem. We got one law left. Okay, and that is for this when you have the logarithm of something raised to an exponent, the power property. I'm going to show you how to calculate this on your calculator. What you want to do first is hit your 7 and then your x squared button. Now hit your log. There's my log base 10. So it is about 1.690. And then now look where that 2 is. That 2 that was in the exponent is now out front. To type this into your calculator, what you want to first calculate is the log of 7. And there's no rule that says you have to do it. It's just smarter to get your function out of the way first. So now I know what the log of 7 is equal to, and then I would do times 2. And we get 1.690. So you can see bringing that 2 out front as a factor still gave us the same result, and that is the power property. If you have log base b of something to the m power, you can rewrite it by bringing that exponent out front, making it a factor, and it's an equivalency. Okay, so the exponent comes out to the front, and you have the same value. So here's our example. Same log base 2 of 3 and log base 2, 7. Figure out the log base 2 of 49. They're trying to be a little tricky here because how do I get a 3 out of a 49? Well, I don't have to use this one. So what I'm going to do is rewrite this as a log base 2 of a 7 squared. And now, because of this property, the power property up there, I can bring that exponent to the front as a factor. So my 2 comes out to the front, and now it's log base 2 of 7. And I know what that is, so my final answer is going to be 2 times 2.807. And now you throw it into your calculator, 2.807 times 2. 5.614. And we're done. Okay, the last ones is the last examples here. Oops. There's a summary of the laws. Product, quotient, and power. And then our last slide here is just a few examples. This time we know log base 6, 5 and log base 6, 8. So we want to be focusing on trying to write these things as combinations of 5s and 8s. I'm not going to go through all the math on these things, but as soon as I see in this first problem this division, I'm going to rewrite that as a subtraction. So log base 6, 5 minus log base 6, 8. And log base 6, 5 is 0.898 minus log base 6, 8, 1.161. Then you get out your calculator and you solve it. You get to your final solution. Let's look at number 2 here. 40 I recognize as 5 times 8, so this is log base 6 of a 5 times 8. And multiplication can be rewritten as addition of the two factors, like so. And log base 6 of 5 is 0.898 plus the 1.161. Get out your calculator, add the two together. Problem 3. Log base 6 of 8 squared. So I bring the 2 out front. It's the power property. So it's going to be 2 times log base 6 of 8 is 1.161. Multiply those, you'll have your solution. And log base 6 of 125, I'm going to rewrite as log base 6 of 5 to the third power. The exponent gets to come out front, the power property. So it's 3 times log base 6 of 5 is 0.898. You do have to do that final step, of course, figure out what that addition or product is equal to. That's it. Your assignment is in a Google form. Try to get that done.